Hello, today we're going to talk about BJT. BJT is bipolar junction transistor. Bi means two, and polar means the end of the something, two end of the something. So let's see this NPN bipolar junction transistor. BJT is considered of emitter, collector, base. Emitter emit the carrier and it goes to the base and it goes to the collector. So like this is NPN BJT. The direction is the direction of this direction point is the direction of current. So NPN transistors, N-type semiconductors meter the carrier is electron. So if the emitter emits electron this way, the current flow the opposite side. So the direction is like this. If we draw the direction of electron, it will be like this. And oppositely, the NPN, let's see the NPN BJT. NPN BJT's whole movement direction and the current movement direction is same. So emitter emits the hole like this and current flow like this way. And let's see the difference between FET and BJT. FET is field effect transistor that we learned before. The control is capacitively coupled to the channel and current flow primarily by drift. But BJT is direct connection made to base and current flow at least in the part by diffusion. Let's see the BJT's operation. By KVL, this is the relation between BJT's voltage. And by KCL, this is the relation between current in BJT. This relation is very important. And let's see the BJT's operation detailedly. First stage is like this. There is barrier between N-type and P-type semiconductor, so currents can't flow. But if we give reverse bias between the base and collector, and forward bias between the emitter and base, the carrier can go like this way, so eventually currents can flow. And in BJT, the gain is very important, so we named the current gain into alpha and the current gain into beta. Alpha and beta's relation is like this, and the relation between alpha and beta is like this. We can express like this. And the mode that we give forward bias in EBJ and reverse bias in CBJ, we call this mode in active mode. This is same as I told you before. And let's solve this question. In this question, this is use same concept. So let's see only this problem. If the collector current is 18 milliampere and base current is 0.5 milliampere, and by KCL we can get the relations by KCL is IE equal IC plus IB. So if we gather this together, we can get the ammeter current. And this is the BJT mode. As I told before, in active mode, EBJ is forward biased and CBJ is reverse biased, and it can use by amplifier. And if we give reverse bias in EBJ and reverse bias in CBJ2, then this is the cutoff mode. We can use this by logic gate. And if we give reverse bias in EBJ and forward bias in CBJ, then it is reverse active. And forward is voltage saturation mode. It can be used logic gate also. And this is the mode operation of BJT and FET IV characteristic diagram. The important thing is the saturation's reason is opposite between these two transistors. In BJT, the first reason is saturation reason, and in FET, the second reason, the later reason, is saturation reason. It is opposite, so it can be a little confused. Okay, it was the review of BJT.